Okay, you guys ready to get started for today? Then you have some time to generate some questions and see where you get. Kind of get the dust off a little bit. Yes or no? Yeah? Okay, so basically what I wanted to start with today was give you guys a chance to ask some questions, get some feedback, because I think a lot of you guys might have some of the same questions or problems that we can address together as a group, hopefully at least, and help everybody out, and kind of touch base on where we finished off with last class and start to pick up some new stuff and work towards, what do we have due on Wednesday?
The draft.
Yeah, we've got a draft of what exactly is the draft of, or exactly the paper, what's comprised in the paper, which sections?
The whole thing, the abstract.
Everything. Yeah, okay, so we have title page, introduction, abstract, methods, procedure, results, discussion, references, figures, tables, all that kind of good stuff. So we've had a lot of time that we've spent up until now, probably about 70 hours or so in class, and homework and whatnot, building into drafts of those individual sections together. So now all you have to do is kind of just bring them together. And so I've spent a lot of time together working on editing some of those drafts of your introduction, your methods, results. So hopefully these things are starting to come together for people. And so if you take it in small manageable chunks like that, then it'll help to get the whole paper to come together. So when we do that, we will be looking again to add in the discussion section a little bit, to add in our references a little bit, add that abstract, which is going to basically be that paragraph summary of the whole thing, and of course add the figures in too. So the figures and results and abstract drafts were due last Wednesday. I only got it from 2 people, so I'm a little concerned that we had a drop-off because a lot of people took advantage of the opportunity to get free feedback and editing without losing any points on the introduction and the methods sections. I put a lot of work into getting you guys tuned up with that stuff and trying to help you guys avoid losing points, but I want to make sure that people stay on track, keeping up with the class, because there's these really good opportunities to keep earning these points, or at least preventing the lost points later by getting our input on the feedback. So those of you guys who turned them in, thank you. And hopefully it'll help you guys to do well. And hopefully it was useful feedback to help you guys figure out how to tailor your stuff up and stay on the right track. So in a couple days then, I'll expect to see that draft of the paper. Now, we started off the class, and this is what the paper will start off with, right, is the review of introducing the topic, but really particularly keying the reader in on what your hypotheses were that you developed. And so developing your hypotheses is something that you've been working on and exploring for the whole semester, and so hopefully you have a pretty good base with that by this point. And the methods are simply the explanation of the procedures by which you went to explore those hypotheses, and then the results would just be the explanation of what it is that you found when you did explore them. Yes, Melissa?
Did you want her paper due before this class, right? Or does it matter anytime that day?
That's a good question. What would you prefer?
11:59.
I'm
All right.
just having a hard time with the data. Like, I'm trying to work with it and then I'm getting lost and stuff.
Okay, so.
But I mean, for me, results actually are hard. It's just I'm having a hard time with data.
Sure. Okay, so why don't we then shoot for it to be due by the end of the day on Wednesday. I will not read a paper and assign any points for anything after 11:59 p.m. So if you want to save me the trouble of reading things and save you the trouble of earning points, turn it in at midnight.
And your time is right?
Huh?
It's in the email, so.
Yeah.
No funny games.
Yeah, no funny games. So we'll try to. Well, we're already extending that to you. If you're gonna make me wait up until midnight, I think that's a pretty fair deal.
You're already up at that time.
How do you know?
Because your email's at 2 a.m.
That's because they responded to the ones I get at 1:30.
You're like 3 a.m. Good morning. It's just
I get woken up by the ones I get in the middle of the night and I respond to them then.
You wake up to small noises like emails?
When your phone blinks off sometimes, yeah.
I have an alarm clock that shakes my bed, so I can't relate.
You're smarter than me with mine. Yeah, Ryan.
I'm gonna mention it, but what is the extra credit paper due?
By next Monday. So we'll do that. So the extra credit paper, remember, of course, we have a visiting speaker coming tomorrow. One of the world leaders in neuroanatomy and neuroscience and really emerging new neuroimaging methods.
Is,
Dr. Yacomonis, yeah.
is he going to talk about patient HM?
Oh yeah.
Right, okay. Just didn't want to get like
Oh yeah.
sad.
No, he'll definitely talk about patient HM.
Okay.
If anybody wants to have lunch with him afterwards, talk to me after class. I'll give you the information about maybe having lunch afterwards. And he was the person who famously led the slicing of patients' HM's postmortem brain. I used to just say slicing his brain, but then that sounded too creepy. So postmortem, of course. And so we have that. It'll be a fantastic presentation. He's usually very, very good. And so please take advantage of that opportunity.
And just to make sure we email you the paper just through your email, just
Yeah.
attach it to an email.
Yeah.
Okay.
Indeed. So anyways, we will talk about some of your data analysis issues and some questions, and we will revisit some of those issues about the results sections, and we will, let's see here. So remember that when you're putting these things together, you should have in your results sections, you will be reporting behavioral results and physiological results. Yes, Richard?
We can just use your that paper that you wrote right as a template for the results. So I think you did that too, right? Behavioral.
Oh yeah.
Okay.
Start with behavior first,
Okay.
then you always go to physiology.
Okay.
And so some of the reasoning behind that is, before we know what's happening in the brain, we want to first know how to interpret that brain activity, but within a context. So first we want to tell, when we are readers, we want the writer or the scientist to tell us, how did the people perform, so that we can understand that first before asking how did their brain activity demonstrate effects. So basically, were the people brain dead? Were they falling asleep during the experiment? Did they perform above chance? These are all really good things to know, right? Because what if I tell you all about the brain activity first, and then I tell you about the behavior, and like, oh yeah, they performed at chance level, they couldn't remember anything. How useful was the time you just spent looking at the ERPs then? Not very much, right? So always start with behavioral results. Start with those, and then go into the physiology. And so you're just basically keeping it simple, and then building into more complexity. So you want to do that. Start with behavior. What's the first behavioral result that you want to show and report? Of what? Standard deviation of what? Average of all the what?
Of all whatever you were talking about, like in like.
That's what my question
What
is.
you're focusing on.
What is the behavioral measurement? What's the first piece of behavior that you want to tell people? What would you like to know as a reader? I just kind of said it a minute ago.
Who the group is?
Well, that would be methods, who the group is.
Oh.
Yeah, you're right. But the...
That's what I'm trying to say. Go ahead.
No. What are you trying to say?
But for the, you're saying what we would like to know behaviorally, right?
Yeah. What do you want to know?
I don't know, like the condition of the people that.
I wouldn't want the mean of the accuracy or reaction.
Yes,
time.
accuracy, yes. Before we even talk about reaction time, you want to tell them how do the people do? Because you just built the whole paper up, right? You talk about introduction, methods, procedure,
Oh,
right? All about the story you're telling your reader about your exploration across the ocean of memory. First thing you want to know is, did they hit land? How did they perform in general? Because that's going to color our interpretation of their speeds and of their physiology. So what measurement would you use to report memory accuracy? Okay, hits would be one thing.
And correct it.
Well, correct rejections can be useful, but in the behavioral sense, not as much as we find them useful in the physiology.
It's a misses.
Not quite. So we talked about this about a month ago.
Oh,
Huh?
oh, yeah.
We talked about comparing hits to false alarms. Remember? So when we talk about our accuracy, okay, we're going to measure that as the proportion of hits minus the proportion of false alarms. Okay? Why is that useful again? Do you guys remember what we talked about on that a while back?
Is it just because, okay, well, the his first, isn't it, you're interpreting how well they remembered, and the false alarm is how well they, what they forgot, right? That they don't necessarily
Is
remember.
false alarm forgetting?
Oh, thinking you saw it, but you didn't.
Ah,
Is
it's a
that-
false memory.
Yeah.
Oh,
I was gonna say, so.
If
when
you think you're remembering, you're not really forgetting, right?
okay.
So it's like you're comparing the two, so you eliminate it was just by chance that they hit this. You're showing it like.
Yeah. So in this case, by the way, what's our condition that we call our hits in our task?
The.
What responses did they receive?
Oh, yeah, it was like
The
a
5
5.
And?
and 4.
Yeah, right? Because we're collapsing across that confidence. So these are going to be old items that receive 4s or 5s, right? What are we calling false alarms in our experiment?
Old items that receives 1 or 2, or no, new items that receive
4.
4 or 5.
Exactly, great job. Okay, so these are new items that receive 4s or 5. Now y is, and again, this is proportion of hits, right? And the proportion of false alarms. So it's going to be that out of basically your number of old trials, and it's going to be that out of your number of new trials. So, why are we using this comparison again? Remember when we talked about this in signal detection framework? As opposed to hits and correct rejections that you mentioned earlier?
Because it shows that they, it shows the percentage of what wasn't left to chance, in terms of how likely was it that they just guessed and had a lucky guess, or did they actually remember it?
Yeah, not as much for this contrast. What we're doing with this one is you're comparing the times when they got the memory right versus the times that they obviously got a false memory. Okay? And it's basically you're getting your accuracy between the same responses given, 4s and 5s. So when they say the same thing, what's the difference in their accuracy essentially? So when we compare the ERPs, we use hits and correct rejections because we're holding the correctness constant. But this is going to be our metric. I've already built this in to your behavioral analysis. So I've already calculated it for you. Okay, all you got to do is just get the numbers and run the t-test. Okay, so in your group files of all your group data, that's already there. It's in one of the first columns. It's there in your individual data analysis subjects, so subjects sheets. So I've already calculated that. But that's the first thing that you want to report in your results section. Okay? So first you want to tell your reader how well did they do behaviorally. So you're going to start off, right? You're going to have your big section of results. And within it, first you're going to have behavioral results. Okay? Now within behavioral results, you're going to talk first about accuracy. Okay? Make sense? Now, when you're comparing these, okay, what's chance performance? Their amnesia, and they can't remember anything. They're HHN. What number would that be on a scale? So you're talking about percentages here. So you're on a scale from 0 to 1. Yes? you might be tempted to think it's 50-50, but in fact this time it's not. Yeah, right. 0.
Because they don't.
0% is chance. Okay, so you might have, and you might want to show a figure of this too. And in fact, you'll see an example of this figure in the 2012 paper in Neuropsychology that we referred to. It's exactly how to put your figure. Okay, you're going to have your table here. You're going to call it memory, or your graph. It will be memory accuracy. Okay, and you can have. It'll go up from 1 to go to 0, and let's say they're usually at about 64, let's say, percent. You might have a graph that looks like that. Okay, 0% is actually a chance line performance
Why 0%?
because you're subtracting 2 percentages, and so just the way that the math works out, if you have so this is when they're saying the same things on the keyboard, right? 4 or 5. And if all they do is just hit that every single time, right? Then they're going to have that same percentage for times when it's new and old, which is basically going to be just about every time. When we subtract those two, it's going to be back to 0. Oh. I guess that's more useful, maybe?
Yeah.
Okay. Yes, Alyssa.
So is the graph saying that anything above 0 is saying that they actually remembered
Better than chance.
better? Okay.
But here's, now you have a statistical question though, right? So just because, and if you look at that paper that I referenced, the 2012 Neuropsychology paper, it's actually a paper on hippocampal amnesia patients. We have another graph that basically comes over here. These are your patients, these are your controls. Okay? Like that. Okay? Now the patients were above chance. They were at here about, let's say, 30%. Okay, so from here to here, they actually performed above chance, but they were still impaired from controls. So the question is, did they perform above chance levels, or were they completely amnesia down here? And that's a statistical question, because you want to know, are they above? They are above chance, but is it statistically reliable? So the way that you do that is basically in Excel, you'll have your column of, let's say, percent hit minus percent false alarm. Okay, you'll have that value for every subject. Okay, and then you're going to have basically chance performance, which is zeros. So you put a line of zeros down here in this column. Okay, and you have your data in each of these spots, and you would run a t-test between that and that to know if it statistically differs from chance. Make sense? I can show you guys that a little bit later in the class if you want to look at it in more detail. Okay? So, we'll come back to that. But anyways, structurally, okay, you're going to report behavioral accuracy. Let me take this stuff off of here just to stay focused. Okay, then we're also going to... Hello? Alright, got the lights back on. We're also going to report reaction times. Okay, then we're going to have another section within the results called electrophysiological results. Electrophysiological results. Okay? And it's here that you're going to report your different comparisons. So let's just say, for example, you're comparing hits versus correct rejections. And you're going to report the results for hits versus correct rejections at, say, whatever sites and whatever latencies that you're measuring. So you might do, let's say, mid-frontal, or parietal, and you might do it from time of, say, 400 to 600, or your time of, let's say, 600 to 900 milliseconds. And you'd have the same here as well. So 400 to 600, 600 to 900 milliseconds. So this is going to be your outline for your results, right? You want to start with something behavioral and finish with physiological. This should be a review because you guys should have drafts of this already put together. Okay? So we have that. Now, what else do we need to include in a results section? What'd you say, Alyssa? Well, yeah, but the t-test, you're right. You want to report what the t-test is for each of these measures. You're going to have t-tests for all of this stuff. So you're right, absolutely. But what other sort of core elements of the results section do we need to include that we haven't talked about here yet? Yes? You're right, the significant difference, but that's what the t-test is going to tell you. What else? Yes?
We can have our figures. And
Figures.
graphs and-
Yes! Figures and graphs and tables and everything else you need. The best part. The stuff that looks cool, that's fun. You gotta put your figures in. So, add your figures. Okay, so don't forget to have those. We are going to have your figures such that you want to have, you want to be able to illustrate anything that you are reporting. Okay? So, show a picture of anything that you say happened. Right? So, as Columbus discovered America, they said, prove it. You have a picture, it didn't happen. Right? Is that right? Somebody says something happened these days on Twitter or Facebook, you're like, prove it. There's not a picture, it didn't happen, right? So we want to make sure that we show some illustrations of the data that we're reporting. What are the things that you want to include on some of those figures, particularly the bar graphs?
Error model.
The accuracy.
Exactly. Error bars. We want to show the variance of the data a little bit. Okay? So anyways, we have that, and we want to, and I'll get into the figures in a little bit more depth maybe next class. We'll see how we get how far we get today. But you guys know how to make figures already. We're going to tune them up and make them better as we move deeper into the class. But we'll start and keep it simple right now with the way that you guys have them. And we're just going to improve them over time. Okay.
Did you see why it's prompting that as well?
Yeah, so if you're going to do, so if you're going to have behavioral results, those might come in the form of bar graphs, right? So you could have bar graphs. Okay. You could, if it's just accuracy, if it's just one value of accuracy, you might not need a bar graph, right? That's just a number. So there's no point. You're going to make if you're going to have a graph like this, and the graph just looks like this, it's not very useful, is it? No. So in that case, you just report the value of what the average accuracy was and say whether or not it differed reliably from chance or from zero in this case. Okay? But if you're going to have reaction times, that's going to have reaction times between different conditions. Different condition here and condition here. Okay? Now, you want to have a title for your graph. You want to have a y-axis, label, and if you, a lot of people had this, at least in the drafts that they submitted, if you have, let's say, hits and correct trajections for your reaction times down here, that'll be fine for your x-axis. You don't have to put something else, you don't have to have another label down here right now for our purposes. Okay? You want to add some error bars. And if you found a significant effect, you might even do your reader a treat and give them a little connecting bar here with an asterisk that shows that it's significant. You guys know that little convention with the asterisk? So let's say you find something that's significant between two conditions at p less than 0.05. You can put a little asterisk on this sort of connecting bar there. Now let's say you find it at p less than .01, you would add 2 asterisks. Let's say it was super duper significant at p less than .001, you would add a 3rd asterisk. And that visually lets your reader digest a lot of information here really easily. Okie doke? Okay, so you're going to have some bar graphs. You're also going to want to include your ERP graphs, and you're going to want to include your topographic maps. Sound good?
I have a question.
Yes, give me 1 second here, just writing down a quick note so I don't forget it. Correlations. Yes.
Okay, so like on the actual experiment at the end, there was like a thought probe, like a question, like how well you think you did. Like,
Yeah, we're not bothering with it for this class.
Oh, okay, because I was gonna look at Dunning-Kruger. Don't do it.
I wouldn't bother with for
Okay.
this class. I think we got bigger fish to
Okay.
fry. We can talk about it later, maybe, because the bigger picture that we're gonna sort of deal with is we're gonna get this paper finished on Wednesday by 11:59, right? Yeah. We're gonna make sure we find a way to get it done. And we're gonna breathe out a nice sigh of relief. And we're gonna have these factors in for our basic hypotheses. And then, for the next section of class, we're gonna add more hypotheses. We're gonna further investigate, we're gonna build more results into this. And perhaps some of your hypotheses might address those issues later. But for now, we're out our hands full. Let's work on getting this basic part done and feel comfortable with it. Get it under our belts, and then we'll take the next steps and some other questions. We can then, in the remaining part of class after Wednesday, we can look into how are your hypotheses affected by damage to the hippocampus. And we can look at how the physiology is affected by patients who might not have the hippocampus and whose physiology you can explore. You can look at how brain states might differ based upon that, and look at the data based on pre-stimulus effects that we'll also talk about Wednesday. We'll start categorizing. We can look at how these correlations might become evident between the physiology and behavior as well. So we have a lot of really next step analysis we can do afterwards. But let's just get there in steps. But good thinking. You're absolutely right. We can get towards those things. So you want to include your figures, and you want to make sure that we also have references in the papers. Do, of course. And this goes back to the very first day of class. Remember, I said obviously you have to try to keep things within APA format. You're going to have to write your references. If you want to write them all out by hand, be my guest. But I highly recommend using a software like EndNote or Mendeley or Zotero. I think they like Zotero here at the library. So I think Zotero is free. EndNote's a couple bucks. I think it's like $80 or something like that for students. So are all great. But if you don't write your references in the right format, I'm not going to give credit for it because it's too easy to do right. It's way too easy to use a free software to just press a couple buttons and get your references in correct. So, yes?
Do you want the DOI available now?
I'm ambivalent to the DOI. DOI is basically a website that you can go to for it. It doesn't matter to me one way or another, so I'm not going to care if you have it or if you don't. But if I would just defer to whatever way the software is just put them in, which usually they just put them in, which is fine. But it's too easy for you guys to get done correctly using the softwares, and it's too much time for me to go through and pick apart the details of your references, whether you used a parentheses or the volume number the right way, when it's so easy to get it correct.
It took like 5 minutes to install Zotero on
Yeah.
Mozilla. It's free for us.
It's super easy. Yeah. Okay, so we got the figures, we got the results, we've got the references, The abstract should have about a sentence or two for each section. So your abstract should have a sentence or two of introduction, a sentence or two of methods, a sentence or two of your results. No statistics. Nobody wants to read numbers in the abstract necessarily, but you want to tell them verbally what was reliable, what was significantly, what was the effect. That's cool. And then you want to have a sentence or two representing your discussion that will tell the reader basically the big take-home message. Why is this important? What does this mean? So when I package that together, you have about 2 sentences for each of that. You've got yourself a nice hefty paragraph. And that's your abstract. Got it. Right. And then of course that leaves us with the last section, the discussion. So the discussion is going to reflect the degree to which you've been doing your homework and doing your literature reviews and reading some background readings, understanding the issues of memory that are driving your hypotheses, and understanding the data that are helping you interpret your tested the hypotheses. And so when you start to write your discussion, this is the point to where you can now start to walk the reader through what does this mean? Okay? So when we get into some of these elements of the discussion, okay, what are some of the things that you either should tell your readers or that as a reader you want the author to tell you about as you start reading a discussion of a scientific research report?
Potential limitations.
Hold on, his hand is up. Yes, right?
I would remind them of your hypothesis.
Great way to start. Right? How many of you guys have read some papers for this class? If your hand's not up, that's a problem, guys. You got to be doing your lit reviews, or you're not going to know what you're writing about. So when you guys read those papers, how many of you guys got to the discussion section after reading the whole big thick results and introduction and methods, and how many of you guys felt really refreshed and revived? No, you're tired. You just read this big long paper. You might even be confused by it all, right? Okay, so a great way to start the discussion, right? Kind of refresh your reader. They might have even taken a break. You gotten a drink of water or something, come back to the paper. Remind them, what did you do? Okay, so you want to kind of reintroduce the main sort of idea or topic, and of course really key people in to what were your hypotheses investigated. And you might even remind them why, of course, you did it. Why is this important? Why is this a big deal? Why should they keep reading what you're writing? You know what I'm saying? Yes, Lisa.
So the first part would basically just be the purpose.
Yeah, you just want to remind people. You're like, what would you want me to do in reminding you about what we found? Right? Lights are acting kind of crazy, huh? Right? Sometimes it's nice to have a little bit of a refresher. Okay? But of course, that's not the main part of the discussion. From the discussion, you're actually discussing, of course, what the results were that you just reported. So the results should be your kind of like robotic, this is the clear data, this is our clear, objective facts. Okay? The discussion is kind of the alternative facts. The discussion is kind of what you think about the facts, what you think it means. You're the tour guide right now. You're guiding the reader to what you think the data probably means. But because most of us are human, there's a chance that we might even be wrong, right? We make some mistakes. Sometimes we're really pretty sure about something, and it turns out years later, oh gosh, I really read that wrong. Any of that ever happen to you guys? Yeah? You were wrong once, Henry? You were mistaken about it? You get it? You were mistaken about being wrong, so you're actually right? Yeah. So, the point is that we want to tell them, place into context, because you're the expert, and your reader isn't the expert. They want to know what you found. Okay? And so, you'll tell them a couple things. What are some important things to have included in your discussion? Yes, Kelsey?
Limitations to your experiment.
Exactly. So we wanted to have some limitations. Okay. Now, yes, Ryan? Nothing? Okay. So you want to tell them some limitations to it because you want to be fair. Because what you're doing at this point is you're no longer sort of like an objective journalist reporting the facts of what you found. You are now an attorney arguing your case. You're now editorializing. You're no longer the newscaster. You're the opinion writer in the newspaper. Okay? You're the editorializing part. So, when you're trying to persuade your jury, trying to persuade your readers, it's helpful for you not to come off as a complete hack, right? It's completely biased, right? What's one way that is compelling for you, hearing someone persuade you with the sales pitch, that helps you to buy into what they're saying and not assume that they're a completely biased hack? What works?
Support evidence for the.
Sure. You do want to support the evidence, and that's what we're going to. That's what you basically talk about in this section here, which is basically discuss the data. Discuss the data, interpretations, implications. Right? So here's what we found. Right? We found the F400 effect in LPC for recollection familiarity in these conditions or whatever. The interpretation of that is that recollection familiarity might be involved in supporting these types of memory judgments that you happen to investigate with your hypothesis and your conditions that you compared. And then you're going to say the implications of that might be that it shows us that, recollection might rely upon a hippocampus, but familiarity doesn't. Those are some examples. Okay? So that's the data, the interpretation of what it means, and the implication of what it means. 3 different things, right? And in between here, sandwiched in between them, these hypotheses, you might even remind them, right? What are the conditions that you compared or analyzed? Okay, remind them. Where did you look? Where did you explore? All this stuff kind of weaves together. Okay? But what's going to make you have a really good, compelling, persuasive case, and for them not to write you off as a hack, right? Just arguing your own biased perspective. You want to do what Kelsey said about note the limitations, right? Isn't it a lot more compelling when someone's like, I really think that this and this is the case, and now you're right, it could also be this and this. But here's the reasons why I think those limitations might not be able to provide a viable account of the data because of this and this. And again, it brings the reader back to sort of supporting your position, right? So you want to use some sort of writing skills here and some persuasion skills. You got to have put some limitations on there. Now you don't want to tell them why your study is entirely crap, because hopefully it's not crap. You don't want to give them the shovel by which to bury you. You know what I'm saying? But you do want to be responsible, ethical, and just show them that you're a responsible, reasonable scientist, and that you do recognize that this is not God's gift to science. Right? This is not the best scientific project ever and solves everything under the sun. It's not perfect. There are some flaws. Here are some limitations of it. And here's what we can't yet deduce. And that walks you down right next to the next section that you want to include, right? Which is that you want to suggest possibly some future studies or future work, future directions, okay? Because that's a very nice way of saying that here's the limit, here's what we found, it's really cool. It's limited by some of these factors, but here's how we can address those factors in the future. Right? So when you submit it to peer review, right, and other scientists read it and they bash it and they go, oh, that's crap. we should not accept this. We shouldn't publish this person's thesis because they just told us the reasons why it's no good or why we shouldn't believe it. You can ameliorate that concern of theirs by saying, sure, it's limited, but you should still publish it because here's the next future steps that it can inspire and motivate in order to resolve these limitations in the future. Make sense? These are all core parts of this discussion that you want to have. And then what are you going to have after this? Yes?
Maybe related to real world like situations, like why it really matters.
Okay, yeah, so you want to have some real world applications. I would tie that into the implications here. The sort of the real world sort of applications and all that kind of stuff. But yeah, you can write a much more broader sort of summary of that here. And where I would put that summary element, that broader application, would be nested under a subheading that you would finish off with, which is hold on, right there. Conclusions. Right? So conclusions is going to be that broader element, right? Where you bring it on home for them. You land the plane safely, and you let them bring them down nice and gentle and say, and this is what we found. Right? It's like that soft ending to a song instead of an abrupt end. Like, oh, what happened?
So we're basically repeating, because I know when I was like learning how to do it, we didn't have the conclusion there. We just did the discussion of the data, we interpreted it, then we did the implications, or the limitations and implications, and then the future studies, and the future studies is kind of like the ending tone of it, like we did this, here's something in the future, and that was it.
Yeah, you can put another couple sentences or a little paragraph of conclusions.
Okay.
Just kind of summarize it back for people. I just think about it as a nice soft landing point. After you've done all these maneuvers and flights and trips everywhere and you've been up in the pad and looping around, bring it in for a nice crescendo. It's like a musical song. You want to end it soft and sweet and let it drift off into the sunset. You know what I'm saying?
Yeah.
Yes, sir. Good question. How long does it need to be? I would say as long as it has to be. As long as you need to say everything that you need to say about what you did and not one word more. Right? Because do you want to read one more word that I have to write? No, I know you don't. Right? You're busy, you got a life, you got stuff to do, whatever. And so, but you do want to read everything that's important, right? So take as much space as you need. Don't get verbose. You're not going to be able to bullshit me. Like, I know the data. I know the topics. So don't try to get all, you don't need to pad it and add pages and pages of fluff. Yeah, exactly, right? Like, you don't want to start, like, pontificating about a bunch of stuff that we don't really know anything about or anything. Brevity, briefness, conciseness is a virtue that I myself have not perfected very much either. And we all need to work on that better. And so, I would have asked it, how short does it need?
That's what I wanted.
What's the miniskirt metaphor?
You want your paper to be long enough to cover the important parts, but short enough to be interesting.
Okay. Trying to think that one through. Long enough to cover the
I think
important
somebody
parts.
told me that in high school or something.
Short enough to be interesting.
Yeah.
Okay, that might work.